is real and scientists just mapped it. Licet ogni speranza, voit entrate, reads the gates to the inferno. Abandon all hope, you who enter, which is a pretty nice way of saying welcome to hell. But there's a real underworld, albeit one with fewer dogs and less being blown around by the wind or wading through shit. Scientists are working on a comprehensive map of it. A map of hell. Kind of. The Earth is made of tectonic plates, immense sections of crust and mantle spreading apart and crushing together, causing things like volcanism, earthquakes and continental drift. Through the process called subduction, one plate can slide beneath another, leaving a section of Earth to descend into the mantle called a slab. A team of European scientists have been working on the Atlas of the Underworld, a map of these slabs, to learn about the Earth's mantle and the history and geography of this subsurface world. They've now published a scientific paper detailing their results in the journal Tectonophysics. Now we can trace not only how plates move over the surface, but how they sink to the core mantle boundary, Nu van Hinsbergen from the University of Utrecht in the Netherlands told Gizmodo. That's the cool thing for me, we can learn about the physics inside the Earth. You may think that plates that sink deep into the mantle just melt, but in fact, they stick around for a long time and can sink as deep as 3,000 kilometers, 1,860 miles, explained Van Hinsbergen. The catalog is the first and extensive global framework for interpretation of present-day global mantle structure and its physical properties and how that relates to our planet's dynamic evolution of the past 300 million years, according to the paper. This hellish atlas is a 17-year-long effort, compiling troves of data from troves of research in which these slabs were imaged. To image these slabs, the researchers used seismic tomography. It's a lot like medical imaging but using the speed of sound waves through the Earth to reconstruct images, rather than light waves interacting with some other surface. The researchers used this information to tell the history of many of the slabs and their effect on the planet. The Bitterroot slab, for example, sits 200 kilometers, 120 miles, below western North America. They infer that the slab could have subducted from 66 to 46 million years ago, causing an ancient area of volcanic activity called the Chaliabsaroka Arc. This 50-million-year-old volcanic area is now only detectable through its leftover rocks in the northwestern United States. Newer slabs leave behind more noticeable features, like the Andes and the Himalaya mountain ranges. One researcher not involved in the paper, Johnny Wu at the University of Houston, told Ars Technica that the project was like a human genome project for planet Earth. Like a human genome map, this will undoubtedly provide a platform for many future discoveries about our planet. It's an ever-evolving effort. If you look at the first World Atlas in the 16th century, that was a pretty good job, but it looks different from our atlas today, said Van Hinsbergen. I think it will look a bit different in 10 or 20 years. We'll probably find slabs here and there. Hell is real. Or at least, lots of land gets sucked onto the mantle as the planet evolves and sticks around, causing noticeable features on the surface and complex behavior in the mantle. You can check out the atlas over at atlasoftheunderworld.org.